Hey guys, hoping all is well with everybody. In this video, we're going to be continuing with the practice algebra exam, starting with question number 17. Question number 17 states that 2x minus 5 is less than 3x plus 1. Now, what I want you to imagine here is that you see an equation that has a variable on both sides. Treat this like any kind of equation. So this inequality here is still standing as its function, but we can approach it the same way as solving any type of double-sided equation, okay? So what we're going to do is we're going to isolate x, and then we're going to solve for what x is in terms of its inequality. So this is what I mean by that. We're going to solve for x by first getting x on the same side, or all on one side. In order to do that, what I'm going to do is I'm going to subtract 2x from both sides. Now, it doesn't matter what you choose, what side you choose to put x on. The reason I'm subtracting 2x from both sides as opposed to 3x from both sides is if you can avoid negative values connected with your variable, it does tend to make things a little easier. So what I mean by that is if I were to subtract 3x from both sides, I would get a negative x here. Not that that's a big deal, but sometimes keeping the positive values just makes things a little simpler. So let's go ahead and do that. I'll subtract 2x from both sides. And when I simplify this, I'm going to get negative 5, because this is going to cancel, because positive 2x minus 2x is 0. Negative 5 is less than 3x, positive 3x minus 2x is x, plus 1. Now all I have to do is isolate x again by undoing what's being done to it. So since x has 1 being added to it, I'm going to subtract 1 from both sides. The reason again why this works is that when I subtract 1 from both sides, this positive 1 and negative 1 cancel, and that's what our goal is. Our goal is to get x all by itself. Now when we take a negative 5, be careful here, because negative values can still be tricky. But negative 5 minus minus 1 is negative 6. And then your inequality stands, and you get x is greater than negative 6. What I like to do with inequalities when I have my variable on the right-hand side, I like to invert it. What I mean by that is the orientation of this sign stays the same in terms of the x value and its quantity, but I like to just have x on the left side. As you're going to notice in standardized tests and other exams that you take, your variable almost all of the time is going to be on the left side with its inequality than the value. So again, x is greater than negative 6. Okay, and we have definitely choice C as our answer there. Okay, alrighty. Now remember, with inequalities, this symbol right here means that x is greater than negative 6. Remember that this sign right here means that x can be greater than or equal to negative 6. We'll look at a couple more examples of these in the next problems. But remember, without the underscore, x cannot equal the value that the inequality is solved for. But with the underscore present, it can equal that specified quantity. Okay, let's look at the next question. Question number 18. Question number 18 states that 15 minus 3a is less than 3. 15 minus 3a is less than 3. Okay, and then our choices for this question are A is 3, B is 4, C is 2. A is -1, and, oh, whoops, I'm sorry, I forgot to put the inequality signs. A is greater than 3, A is greater than 4, A is greater than 2, A is less than -1, and A is less than 5. Okay, now, again, remember with these types of problems, this time we only have the variable already on one side. It's not on both sides of our equation. So we already can save ourselves from having to do that step. But we still need to isolate the variable to get the inequality directly equal to some value with the corresponding variable. What I mean by that is we have to get A by itself by undoing what's being done to it to both sides of this inequality. Remember, we can still act like this is an equation, but it still does have the properties of an inequality. Okay, so to start, let's subtract 15 from both sides. Okay. And we're going to get that -3a is less than 3 minus 15 is a -12. Okay, so remember, our goal here is to isolate x, and we're able to do so by undoing what's being done to it. So because this is a positive 15, -3a has 15 being added to it. So we're going to do the opposite of addition of 15, which is a subtraction of 15. You know that this works, and you're doing it correctly, when you have positive 15 minus 15 cancel out to 0. Okay, and then again, you just have to do it to the other side to keep things balanced, just like that balance scale. Now we have -3a is less than -12. You have to be extremely careful here. Here's what you're going to do. You're still going to isolate x, or in this case a, any way that you would in other inequalities. We're going to here divide by -3. Here is where things get tricky. When you divide or multiply an inequality by a negative value, you must flip the inequality sign. So because we divided here by a -3, a negative value, we're going to flip this sign. So what I mean by that is that this variable a is now isolated, because think about it, -3 divided by 3 is 1. And as opposed to the identity of a addition of 0, this is the identity of multiplying by 1. It doesn't change the equation, okay? So now we have a. Now we have to flip this inequality to keep things balanced and legit. So now that we've done the negative division, we flip the sign, and then we just go ahead with the arithmetic on the other side. -12 divided by -3 is a positive 4. So our answer is going to be that a is greater than positive 4, which is indeed our choice B. So remember, the most important thing in this question is to remember that when you divide or multiply by a negative number, you have to flip or invert the sign once you isolate the variable. You don't have to isolate, or you don't have to flip the sides that the variable and the value are on. You simply just have to flip the sign itself. Okay? Alright, so choice B, a greater than 4, is our answer. And remember, a has to be greater than positive 4. It cannot equal it. Alright, let's look at one more question. So this is question number 19. Question number 19 states that x minus 2x plus 7 is greater than 15x plus 15 plus 3x. Okay, and then our choices are negative 8x is less than negative 2, x is less than 2, x is greater or less than negative 8, x is greater than 12, and x is greater than 0. Okay, now it seems like there's a lot going on in this question, but I promise you it's not as daunting or as intimidating as it looks. Basically what they want you to do in this question here is they want you to combine your like terms first before you solve the inequality itself. What I mean by that is, notice that there's an x minus 2x here and a 3x over here. They want you to get x together, and they want you to still isolate it on both sides. Again, we can choose which side to have x on, but again, it helps to kind of avoid negatives if you can. And the reason I kind of refer to that is our example from the last question where we have to divide by a negative and flip the inequality. It's not that that's hard or tedious, it's just an extra step that you can possibly avoid if you dodge negatives in the early beginning. So remember, we're going to simplify this first. So x minus 2x is a negative 1x, so negative x plus 7 is greater than 15 plus 3x. Now I'm going to add x to both sides, and this is going to allow me to get x all on one side. So now I have 7 is greater than 15 plus 4x. Okay. Now I'm going to subtract 15 from both sides, and again this is going to allow me to isolate x further, because 15 plus 15 minus 15 is 0. 7 minus 15 is a negative 8. So now I have that 4x, because this is going to cancel, is less than negative 8. Then all I have to do is divide 4 by both sides, and I'm going to get that x is less than negative 2. And again, I personally like to have x on my left side of the inequality, but make sure that it is in the same orientation in terms of how it relates to the value. So this is x is less than negative 2. I'm just going to rewrite that as x is less than negative 2, which is indeed one of our choices, choice letter A. Okay? So remember with this one, you just want to combine your like terms first. Remember that like terms are the same variables of a term, and they also have the variables going to the same exponents. In this question you see that all the exponents are 1, but you may further along see it in terms of having multiple variables with multiple exponents. So just be very vigilant of that. After you combine your like terms, all you have to do is combine your like terms to have your variable on one side of your inequality and able to isolate it. Okay? Alright, so this is, if you guys have any questions, as always, never hesitate to contact me. Or if you guys have any special requests for example problems, never hesitate to contact me as well. I'd be more than happy to do those for you. But I hope this video helps you guys out, and I'll look forward to seeing you in the next video. Thanks for watching, guys. Bye.